streaming. So now, I see myself. Excellent. There I am. Do I sound good? Excellent. There I am. I sound great. Do I sound good? Excellent. Oh, no, I'm getting there I am. I sound great. Wait, it's capturing my... Do I sound good? Excellent. Why would it be capturing audio? I can mute that. I just want lav, so timer... Actually, timer can go. YouTube chat will mute. Oh wait, timer... I probably don't want timer to go either. So now I can skip to live and unmute myself. And do I sound normal? There's no echoing? Do I sound normal? There's no echoing? It is, I need my noise gate back. I need my noise gate back. Okay, lav, filters, add, noise gate. I don't know what to fucking make it. This sounds good though. We'll set it at default settings. Okay. Now what? I want my chat back. I can pop this out. Pop out chat. Nice. Okay, and then YouTube chat, properties, window capture, Firefox, live streaming, YouTube. Nope, not that fucking entire thing. That looks great. All right, now it's massive on screen here. Why is it so fucking big? What the fuck? Do like something like that? Does that help? That helps significantly. Okay. Can I have these windows open at the same fucking time? Okay, there we go. Oh, my laundry just finished. Okay. Boom. That looks great, yeah? Well, besides where I can talk, or I can chat, because I'm not going to be doing that. I can probably just crop that out. Transformation. No, that's transitions. Transform, edit, transform, bottom. We will absorb it. All right, almost there. Boom. Probably. Let's make it an even number. Okay. And Will doing this. Fuck up. No. Looks great. Okay, amazing. I'm about to click this pop-up. Learn more. No, I don't want to learn more. Will it go away if someone chats? If I say like, test, yo, test. Yeah, that looks great. Oh, and it comes from the bottom. Okay, cool. Good, good, good. All right, so now we're studying. Put some text on the screen. Title text. Okay. Text. Studying. What am I going to be studying? I just studying. I just am studying. That's it. Okay. Studying. What are we studying right now? We're fucking studying environmental science or some shit? I don't know. Should I do sloshed on red wine? Sorry. I liked that there was like words up there though. Studying for I'm studying for, what's my major? Business? Business major. That's what we'll say. Studying for business major. Studying for business major. Here we are. Okay. Cool. Fucking Christ. All right. So if I rearrange, no, I don't want to do that. No, fucking hate streaming. That'll rearrange the size of everything. Okay, I don't want to do that. All right, I have laundry to flip. Am I literally live right now? I wouldn't know. Chat rate 2. What does that mean? Concurrent viewers, none. No one's here. Okay, so then I'm actually live. Stream health. Stream is healthy. That's fucking sick. The stream's healthy. All right. So I'm actually streaming right now. I'm live after the internet. Great. Okay. Well, I have to flip my laundry and the studying timer isn't started yet. So can I get like let me do one of these real quick. Text BRB. The text is going to say BRB. I can enable it and then I can drag it over this like whole thing. And then I would love, because I can hide that and unhide that. Sick. Okay. And then can I get like a little dancing guy? Or is that too much? No, I want a little dancing guy. Giphy. Giphy. A little fucking let me search! Dancing cat. Oh shit. There's so many dancing cats. What about like just regular, are there like any good BRB gifts? There are. Not really, actually. Okay, well, this is really not that important, actually. I liked the dancing cats better. Dancing cats. Yeah, let me steal this. Whose art is this? 10 million views? I can't steal this. All right, I don't need to hear myself anymore. Mute myself. Well, all of these suck. I liked this one the best. But I'm stealing. Okay, well then I just can't steal. It's probably for the better. Let me go fucking switch my laundry. Check this out. Oh, wow. Whoa, it says BRB. That's crazy. Okay, I'm back. Okay, well, it is time to start studying for realsies this time. So, pop that in the corner there, and then get my actual studying material out there. All right. Perfect. And you like that. That's fine. Yeah, that's perfectly fine. Okay, so theoretically now, open pop-up timer and press go. We're studying right now. Okay? Where's my pen? All right. I am studying environmental science today. I need to read chapter 4. I don't know why. It's an e-ink tablet. I guess I was proud that I have an e-ink tablet. Okay. We're reading. Reading time. The fuck, dude, my house is shaking. Helicopter. The timer is going. All right. Chapter 4:1. Is this where we started? Where's my menu? Hey, where's my menu? Wait, oh yeah, here we go. So, evolution, biological communities, and species interactions. Interesting. Cool, I'm not reading any of that. Seagrass. Who needs that? We probably need seagrass really much, like really bad actually. Okay, get my brightness up a little bit. Evolution produces species diversity. Natural selection acting on spontaneous mutations results in... Oh, I should have music! Oh. Oh well, we'll get better at this. I've already got a timer and the chat, which is pretty fucking sick in my books. So let's launch this assignment. My session's timed out. Ah, great. Thank God. Okay, cool. We're reading chapter 4. Weird line. Doing like... What? That's not the face it's being... Oh, it's showing this face. Ooh, right? It's like up here too. Weird. Oh my God. Natural selection acting on spontaneous... Oh my God, dude, I actually can't focus right now. Gotta pull like one of these. Block my screens, I can't see. I will learn to not look at that. Natural selection acting on spontaneous mutations results in evolution. Natural diversity develops as species allocate resources. All species have environmental tolerance limits, some narrower than others. So this is about evolution produces species diversity. All right, so we're talking about evolution and how species get more and more diverse. That makes sense. I've never actually thought about that before, but that makes sense. What mechanisms promote the greatest variety of species on Earth? And what determines which species will survive in one environment but not another? In this section, we examine 1. The process of evolution, which includes reproduction, variation, natural selection, and adaptation. Should I mute myself for this? It's not really like body doubling if I'm talking. You're not going to be able to focus on what you're doing. You're just going to mute my stream. Maybe that's not a bad thing. Okay. We examine 1, the process of evolution, which includes reproduction, variation, natural selection, and adaptation. 2, the limitations species face in their environments and implications for their survival. 3, the characteristics of species that make some of them ubiquitous and others rare. And 4, the use of taxonomy to describe relationships between the vast complexity of organisms on Earth. We'll start with the basics. How do species arise? It's a good question. How do species arise? Benchmark data. Among the ideas and values in this chapter, the following are a few worth remembering. 10 liters. Amount of oxygen 1 meter squared of seagrass generates each day. That seems like a lot. 1 square meter of oxygen produces 10, of seagrass produces 10 liters of oxygen every day. That seems really like a lot. 1,000. Number of species that may occurs. Is that actually a typo in this book? It's an X. I think it's supposed to say occur, but there's actually an X in it. Number of species that may occur in a seagrass meadow. Wow. 5-to-1 ratio of carbon capture and storage in a coastal wetland, tropical forest. Shit. That's a lot. This is some scary stuff. 100 trillion, approximate number of cells in your body. 10%, proportion of those cells that are mammalian. What? 10%? 10% proportion of those cells that are mammalian. They're 10% of our cells are mammalian, mammals? Of being from mammals? What are the rest? 1/10 biological productivity of a desert compared to a rainforest. Fuck. 6, number of kingdoms representing all of life on Earth. Yeah, that's just some good basic information for everyone to know about. Okay. The basic idea of evolution is that species change over generations because individuals compete for scarce resources. The theory of evolution through natural selection was established most notably by Charles Darwin, 1809-1882. Damn, that guy lived a long time. Darwin's ideas on how species originate are generally traced to his visit to the Galapagos Islands in 1835, when he was serving as the ship naturalist on the Beagle, a ship sent to survey the coast of South America. Darwin's job was to collect specimens and record observations of the natural world, and in the Galapagos Islands in particular, he was fascinated by the variety of unusual creatures, most occurring only in the Galapagos. Like other naturalists, Darwin was intrigued by the question of how such variety came to be. Most Europeans at the time believed that all living things had existed, unchanged, since a moment of divine creation, just a few thousand years ago. But Darwin had observed fossils and vanished creatures in South America, and he had read the new theories of geologist Charles Lyell, 1797-1875, who argued that fossils showed that the world was much older than previously thought, and that species could undergo gradual but profound change over time. He also knew Thomas Malthus's theory that competition for scarce resources can determine survival. Interesting stuff. Maybe review. Oh, I hate that shit so much. Observing that dog breeders created new varieties of dogs, from Dachshunds to Great Danes, by selecting for certain traits, Darwin proposed that natural selection could explain the origins of species. Just as dog breeders favored individuals with particular characteristics, such as long legs or short noses, environmental conditions in an area could favor certain characteristics. Darwin proposed that individuals with traits suitable for their environment are the best competitors for scarce resources. As those individuals survive and reproduce, their traits eventually become common in the population. The evolution of species through natural selection is now a cornerstone of biology and its many subfields, from ecology to medicine and healthcare. Let's take a closer look at how this process works. I think next. Never mind. Evolution occurs through reproduction, variation, and natural selection. Evolution is a gradual process that results from three observable phenomena. The first is replication, which occurs through reproduction. The second is the variation in traits that exist in a population. And the third is the process of selection, non-random survival of offspring. Evolution is the unintended consequence of these three somewhat independent, observable facts of nature. That seems like a pretty important thing to underline. Why is my house shaking again? Okay, we're fine. Not used to seeing myself from this side angle. A logical sequence of events occurs in the process of evolution, so let's start at the beginning. The building blocks of evolution are formed during procreation, when parents produce offspring through sexual reproduction. Oof. This can happen through an asexual process, but it largely occurs when sperm and egg cells fuse together. The parental DNA builds offspring organisms that are near copies of the parents, but sometimes a gene of an individual plant or animal mutates or changes by accident. Mutations, which I can look at the definition of this. Mutations, a change either spontaneous or by external force factors in the genetic material of a cell. Mutations in the gametes, the sex cells, can be inherited by future generations of organisms. I knew that, I just wanted to get the definition out there to the world, to the public. So mutations in reproductive cells, gametes, can be passed on from generation to generation. These random mutations occur occasionally in any population. Arbitrary errors in DNA, replication, and exposure to radiation or toxic materials are the main causes of mutations. Errors or exposure to radiation or toxic materials. That's insane. So either the human body just fucked up, or you're exposed to toxic chemicals. That's the only way to mutate that we know of. So how do we know the Galapagos Islands weren't just toxic? Joking, obviously. This is half an entertaining stream. I guess it's less body doubling and more I'm going to study. Be with me while I study. And I'm gonna crack jokes. Yeah, most mutations have no effect on fitness. Interesting. When genes mutate, they often yield a slight variation. For example, a difference in visual acuity, length of limbs, or feather coloring. I actually don't know the definition of acuity. Maybe I should look it up. Maybe I should look up the definition of acuity. Acuity. It's an insurance company. Acuteness of vision or perception. Keenness. Sharpness or acuteness, as of a needle, wit, etc. A quick and penetrating intelligence. I admired the keenness of his mind. Well, what the fuck? We're talking about acuity. What are you talking about keenness? Okay, acuteness of vision or perception. So they said, where the fuck are we? When genes mutate, they often yield a slight variation. For example, a difference in visual acuity. Oh, so like how well they see? Maybe? Consider the evolution of giraffes, for example. Among herbivores in a savanna, When trees are an important year-round source of vegetation, those able to reach higher have access to more food. Individuals that happen to have longer necks are likely to be more vigorous and more likely to survive and reproduce, compared to those that can't reach quite as high. When accidental mutations produce individuals with long necks, those traits are likely to become dominant in a population. That checks out. That makes sense to me. The caption to this image of a giraffe says, "Giraffes don't have long necks because they stretch to reach treetop leaves, but those giraffes that happen to have longer necks got more food and had more offspring, so the trait became prevalent in the population." Giraffes don't have long necks because they stretch to reach treetop leaves. But, like, they kind of do. You can't just say, like, you have a feature just because you do, and so then you happen to be able to eat more food and then procreate better than the rest. That's how evolution works. You do have a long neck to eat tall tree leaves. That's what your species has been doing for who knows how long. It's a lie. It's a conspiracy. I'm over here. I want to sit like this, but I'm like in the corner. I have to sit center like this in order to be in the camera. Is anyone chatting? No. It's just me. Oh well, that's fine. All right. Adaptation. The acquisition of traits that allow a species to survive in its environment is one of the most important concepts in biology. In evolutionary terms, adaptation affects populations, not individuals. Adaptation in a species happens over generations, as individual organisms that inherit advantageous traits persist, and other organisms which do not carry the advantageous trait die out. The process of better selected individuals passing their traits to the next generation is called natural selection. Natural selection helps explain how environmental conditions in a particular area can favor certain traits or characteristics. It occurs when the conditions of a particular environmental setting exert selective pressures on species, and over time the characteristics that help the species survive and reproduce persist. This is neither a random process, nor is it an intentional process that acts with a particular goal in mind. It's just that some trait variations worked better than others at a certain time, and their careers were more likely to survive and leave offspring with the same variations. There is no ultimate goal, intended outcome, or ladder of progress inherent in evolution. Yeah, I mean that all checks out to me. All species live within limits. No individual, population, or species can increase without limits. Under normal conditions, growth is limited by the availability of resources within the system or by external factors in the environment. A limiting factor can be anything that constrains the growth of an organism or a population, such as competition for space, food, nesting sites, etc., predation. What the fuck am I reading? A limiting factor. When are we talking about limiting factors? No individual population or species can increase without limits. Oh, okay, sure. A limiting factor can be anything that constrains the growth of an organism or a population, such as competition for space, food, nesting sites, etc., predation, when either predator or prey populations increase or decrease, parasitism or disease, including the number of parasites or the number of disease-carrying organisms, climate and weather changes like drought or heat waves, or human disturbance, pollution, habitat destruction. Those are limiting factors. Let's get the book definition of limiting factor. Anything that affects the growth of an organism or population. Okay, what if it positively affects it? Is that a limiting factor? My timer is frozen. What happened to my timer? Surely the timer's not frozen. No, it just stopped appearing on screen. Oh man. The timer has to be... Okay, well then I have to make this... How do I make this an always on top timer? I don't know if I can. I think I've got to do one of these. Oh! It's still going, but now I can't see. I don't understand streaming. I can probably just get a fucking OBS extension or something that does this. Okay, limiting factors. We understand those. In 1840, the chemist Justus von Liebig proposed that growth is controlled not by the total amount of resources available, but by the scarcest resource. He asserted that there is always a single limiting factor or a crucial factor that determines where a species lives. The giant saguaro cactus, which grows in the dry, hot Sonoran Desert of southern Arizona and northern Mexico, offers an example. Saguaros are tolerant of extreme heat and drought, intense sunlight, and nutrient-poor soils, but are extremely sensitive to freezing temperatures. A single winter night with temperatures below freezing for 12 or more hours kills growing tips on the branches, preventing further development. Thus, the northern edge of the saguaro's range corresponds to a zone where freezing temperatures last less than half a day at any time. That's so interesting. I didn't know that. Ecologist Victor Shelford later explained Liebig's principle. Wait, this dude lived from 1877 to 1968? God damn, a lot happened during that time. 1870, he was born 1877. So this guy is having thoughts and thinking things like a little less than 10 years after that. So 1887. This guy's dad, no doubt, was like American Civil War time. And then he saw World War I, World War II. This guy lived during an insane... He must have thought the world was going to shit. That's crazy. Victor Shelford. What a guy. Later expanded Liebig's principle by stating that for each species, the environmental factor has a range of specific minimum and maximum levels that determine the species' success. He called these tolerance limits chemical or physical factors that limit the existence, growth, abundance, or distribution of an organism. So that is similar to what we were just reading about with a limiting factor, kind of. Beyond which a particular species cannot survive or is unable to produce. Okay. The single factor closest to these survival limits, Shelford postulated, is the critical factor that dictates where a particular organism can live. At one time, ecologists tried to identify unique factors limiting the growth of every plant and animal population. We now know that several factors working together usually determines a species distribution. If you ever explore the rocky coasts of New England or the Pacific Northwest, you might notice that mussels and barnacles grow thickly in the intertidal zone, the place between high and low tides. I have noticed that. No one factor decides this pattern. Instead, the distribution of these animals is determined by a combination of temperature extremes, drying time between tides, salt concentrations, competitors, and food availability. And then there's an image here, figure 4.4. Tolerance limits affect species distributions. For every environmental factor, there is an optimal range within which a species lives or reproduces most easily, so abundance is high. The horizontal axis here could represent a factor such as temperature, rainfall, vegetation height, or the availability of some critical resource. So they're showing where the mussels and barnacles grow. No, these are butterflies. All right. They look sort of similar. I'm not reading this anymore. In some species, tolerance limits affect the distribution of young organisms differently than they affect adults. The desert pupfish, for instance, lives in small, isolated populations in warm springs in the northern Sonoran Desert. Pupfish in warm springs? I thought it was a desert. How are there warm springs in the desert? You got 30 seconds. 30 seconds more reading. So we got, where did the pupfish? Yeah, okay. That's a really cute name. Eggs and juvenile fish, however, can survive only between 20 and 36 C and are killed by high salt levels. Reproduction, therefore, is limited to a small part of the range of the adult fish. All right. Well, it's essentially break time here. So, books down, everybody. We gotta, let's see what sound this makes. Oh my God! You can't hear that noise, but that was the worst noise I have ever heard in my life. If the government was trying to like take over my laptop or like warn me of an impending meteor, that's the noise that it would make. Why did they choose that? Christ. It just was like a single tone, like boop, 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 boop. Oh my God, that's awful. All right, well, so we have 5 minutes break now. How do I maybe I have to make another pop-up timer? I'd like to make another pop-up timer. Hopefully it doesn't replace the one I have. A 5-minute pop-up timer. Can I change the sound that makes? Advanced. Oh God. No, I don't want to do that. Well, you all don't hear the sound, so maybe I can save you from hearing that sound. What is going on with my hair? Is this shadow? It's just shadow. Okay. I thought there was like blue. Okay. So 5 minutes. So now, okay, I need to create another capture. Is it scene? Media source. Media source. No, it's not media source. What did I do with that? Media source. Okay, delete that. We don't want media source. We want, what is this? With these little icons. Screen capture. Screen capture. All right. Here's my entire screen for you all to see. We want this. No, that's the wrong one. We want this. Yes. Okay. And then, okay, I can do this. Give me 1 second. Transform, edit, transform. I think it was 145, 135. Well, that's probably good enough, to be honest. And I'll just that in the same corner with the same, and then I can turn that on and off. Oh, it's a little wrong. I don't really know how it's a little wrong. Did that fix it? It's good enough. Whatever. Who cares? Okay. It's break timer time, so we can chill out and talk and hang out for the next 5 minutes. There's no one here. I'm just by myself in this room. I need like something to hold my hair back. A hair tie, but my hair's not quite long enough for a hair tie. I need like I have a hoodie. Hoodie's kind of annoying though. I guess that's good enough. But also like I like seeing my hair. I just want it to be held back, you know? Headband. I don't know where one is. Mm. Shit, see the window's gone again. Where'd the window go? This timer sucks. Oh my gosh. Wonder, does that leak my email? No, it doesn't. All right, I can just kind of like have that down there, and if I click away, it's still going. Yeah, why don't I do that to the both of them? Go away down here. Okay, beautiful. So how's it going, everyone? What are you studying? If people were here, what would I be saying? Oh, hey, how's it going? Oh, thanks for the donos. Thank you so much. It's so kind of you to donate $20 trillion to my stream. I just started streaming. Thank you so much. That means so much to me. I'm going to go. Eyebrows are so light. Donate. Hey, next person to donate $20 trillion, I'm gonna fix my eyebrows like they are. Like, this is some good color here and here, and then it's like, haha, oh. Like, you can see them, but it's just like, it could be better. Just that it could be better. Studying for business major. And I'm reading about environmental science. Lego skeleton. Lego skellington. Is it just the Yogscast that said skellington, or is that like a UK thing? No one, even if there were like 1,000 people here, I don't think anyone would know the answer to that. Because no one knows who the fuck the Yogscast are anymore. If you're over the age of 20 something, maybe you watched the Yogscast. But like, I don't think anyone on the platform right now would probably understand. How do you get people, YouTube, how do I get people to come to my streams? Just like put a bot in the stream even. Just like give me something to talk to. Maybe I should code a bot and put the bot in the stream. I say that like I can code. I don't know how to do that. But like maybe, cause like that would be fun. Just like, I don't know. Is this just like where is it how they say like the cutting room floor? I don't know what that means, but like is this where I cut my teeth? I think is where that comes. Is this where I cut my teeth? My teeth kind of look white. They kind of look white. All right, one more minute of goofing around, gagging, not gagging. Don't take that out of fucking whatever. We're goofing around. Blueberry muffin? Anyone? It's for my brain, so I can get smart. Blueberries are good for you. Hey, what does this say about me? This box has one of those like perforated pull tabs. I didn't open it that way. Maybe I didn't see it. Oh my god. Sorry. Stop. Stop it. Oh god, it's gone. I can't find it anymore. Stop it. Christ. Okay. Fucking hell. All right. I want munchy crunchies while I eat. I got like a... How far does this mic go? Can I just go and grab these granola? Oh shit, I can. All right, what have we got? The study snacks. We got protein trail mix, raisins, almonds, cashews, pumpkin seeds. This just became a food review channel. Let's see, we got raisins, almonds, cashews, pumpkin seeds. I wonder how loud. So like right now talking, it's actually, as I'm talking, going into the red. So I need to turn that down a little bit. All right, minus 1.5 dB. That might be, I don't know what that means. Crunch time. Yeah, you know what? They're pretty good. Mmm. That's so good. Normally raisins are like small and really chewy, but these raisins are like good. I mean, look at this. That's a big raisin. And it's like got some hydration in it still. It's not like just sour and fucked. Mmm. Okay. I'm fucking around. A muff puppet. It's time to study. We're studying now. Come on. Well, I had a viewer one time. Someone clicked on this once. And they watched for 1 minute and 56 seconds. They actually showed up 30 minutes ago. Wow. Interesting. I have no way of knowing if anyone's here or not. I've been streaming for 48 minutes and I've only studied for 25. How's that possible? All right. Well, it's time to hop back on it. The studying. Time to start studying again. All right. Munching time. I have my beer. I have my beer. I have my beer. Camera angle. I have a camera angle idea. I don't have much room to do this actually. I want it to be farther back. Hello? Hi. Here I am. Look, you can see like more of me. And so like when I'm reading my book now, you can see that I'm like reading my book. I'm just so smart. I'm gonna bite my tongue off if I do that. Wait. There we go. Wow. Wow, you can see me studying now. I'm not just faking it. I think so much a better camera angle. Okay. Time to fucking study. Let's go. All right. Dude, I have 0 drop frames. Best streamer of all time? I didn't say it. All right. So, 25 minutes. Go. See how many concurrent viewers, chat rate. Yeah, that's all I care about. So I want to make this another window. You can see when someone shows up. Yeah. Yeah. All right. Okay. Enough messing about. All right. In some species, tolerance limit affects the distribution of young organisms differently than they affect. Oh my god! Shit me! Oh, I actually did not feel that coming in any way whatsoever. Christ! Oh my god. Alright. Let's just start. I'm scared. In some species, tolerance limits affect the distribution of young organisms differently than they affect adults. The desert pupfish, for instance, lives in small, isolated populations in warm springs in the northern Sonoran Desert. I've already read this! Okay, I think I was down here. Wait, I don't remember this. Where was I? Wait, have I not already read this? No, I read that part. I did read that. Okay, I read that. Okay. Okay, stop it. I know where I am now, okay? Let's calm down. Christ. Sometimes the sensitivity of a particular species makes it a useful indicator species, one that indicates the presence of particular environmental conditions. The presence or absence of an indicator species can reveal something about the community and the ecosystem as a whole. Lichens and eastern white pine, for example, are indicators of air pollution because they are extremely sensitive to sulfur dioxide and ozone, respectively. Similarly, anglers know that trout species require cool, clean, oxygen-rich water. The presence or absence of trout is used as an indicator of water quality. Yeah, I like that. That makes sense. That was good. It makes sense, is what I meant. It makes sense. Oh, shit. Almond! I got it. Oh, fuck. Okay. Look. Why did I choose granola? I fucking can't read. They printed it twice. Oh. An ecological niche is a species' environment and its ecological role. A key habitat is the place or set of environmental conditions in which a particular organism lives. The term ecological niche is a more functional term that refers to a species' role in an ecosystem, how it uses its habitat. All right, we have a definition here. Definition time, let's go! Definition time in chat right now. Spam it. The functional role and position of a species, population, within a community or an ecosystem, including what resources it uses, how and when it uses the resource, and how it interacts with other populations. That's ecological niche. Okay, interesting. The term ecological niche is a more functional term that refers to a species' role in an ecosystem, how it uses its habitat, and how other organisms in the habitat use that species, as well as the habitat it occupies. The concept of an ecological niche was first defined in 1927 by the British ecologist Charles Elton. To Elton, each species had a role in a biological community, and the niche defined that species' way of obtaining food, the relationship it had with other species, and the services it provided to its community. Okay. 30 years later, the American limnologist. What does a limnologist do? Limnologist. Limnology is the study of inland aquatic ecosystems. It includes aspects of the biological, chemical, physical, and geological characteristics of fresh and saline, natural and man-made bodies of water. This includes the study of lakes, reservoirs, ponds, rivers, springs, streams, wetlands, and groundwater. Water systems are often categorized as either running or standing. All right. So, water that is not the ocean, basically. Interesting. What a weird distinction to make, though. Like, you go to school and it's like, I want to study water. And they're like, do you want to study the ocean? And you're like, fuck no. I'm studying everything besides the ocean. Get that shit away. I hate the ocean. No one I know likes the ocean. I'm going to study reservoirs, lakes, ponds, rivers, springs, streams, wetlands, groundwater, not that ocean shit. No. Whoever made that decision? Why'd they do that? That's such a weird like hill to die on. Whatever. So limnology, everybody. Put that definition, spam definitions in chat. Mouse is rumbling again. 30 years later, the American limnologist G.E. Hutchinson refined the definition of a niche to include physical and chemical conditions. What the hell? I'm getting text messages. Hold on 1 second. Pause the timer. Like that's even relevant. Interesting. Interesting things on here that you'll never know about. All right. All right. Start the timers back up. He refined the definition of a niche to include physical and chemical conditions such as temperature, light levels, acidity, humidity, or salinity. Hutchinson emphasized that these physical conditions occurred within a set of biological interactions such as the presence of predators or prey or the availability of nutritional resources. I thought I was going to burp. Some species may be more flexible in their niche than others. Those that have greater niche flexibility can tolerate a wide range of habitat conditions or exploit a wide range of resources. These species are known as generalists. Definition time. Species that can tolerate a wide range of conditions or exploit a wide range of resources. Well, they basically just gave it to us. Not a real canon definition time. A species can be a dietary generalists, like the raccoon, who are omnivores and eat many different types of food, including human garbage. Or they can be a habitat generalist, with the ability to live in many different habitat types, like the red fox. Vulpes vulpes. The most widely distributed wild carnivore in the world. Oh, that's a continuation of that sentence. Foxes. Many generalists have large geographic ranges, as in the case of the black bear, which is omnivorous, abundant, and ranges across most of North America's forested regions. We consider some generalists to be a nuisance or a pest, such as rats, cockroaches, or dandelions. No, dandelions are fantastic. Why is that in this book? Dandelions, no one understands dandelions. Dandelions' roots go way deeper than like most other plants, and they tap down in the ground and they pull up like heavy nutrients and they bring them to the top of the soil so that other plants can have them. That's like, you ever cut a dandelion and it's like milky? It's like calcium or some shit. Like there's something that they're making, and they break up like trodden on ground. Like the ground gets like compacted, and they like help soften it. And then everyone's like, weeds, fuck the weeds, kill the dandelions. No one gets it that they're good. And also, if you stopped fucking with your land, then dandelions would fix it and then go away. Like, you don't see dandelions in like beautiful forests because there's no need for them there. They only show up in disgusting trodden on land that you keep fucking pesticiding. Anyways. Where am I? Oh yeah, nuisance generalists. Other generalist species like deer, aspen trees, or wild turkeys are looked on more favorably. Yeah, they sure are. Alright, while generalists can exploit a wide range of resources or habitat, some species are specialists that occupy a narrow ecological niche. Over long periods of time, through the process of adaptation, natural selection, and evolution, these species developed features that allow them to live in a very limited set of conditions. Oh, definition time! A species that tolerates a narrow range of conditions or exploits a narrow range of resources. We just read that. So, again, false definition time, unfortunately. Over long periods of time, through the process of adaptation, natural selection, and evolution, these species developed features that allowed them to live in a very limited set of conditions. Some specialists eat plants or animals that are toxic or undesirable to other species. Others live in very dry or nutrient-poor areas that few... The fuck was that? Why is there always some fucking weird fuck-ass noises happening in this house? I'm trying to read! And I lost my place. They eat toxic shit other people don't want to eat. Others live, this is specialists we're talking about, others live in very dry or nutrient-poor areas that few other species can tolerate, filling a niche opportunity. As we saw with generalists, a species can be a dietary specialist, like the koala, which only eats leaves from eucalyptus trees, or a habitat specialist like the kirtlet warbler that requires a very specific forest type and stage of forest growth. Young Jack pine, if anyone was curious what the kirtlet warbler can live in, it's young Jack pines. The giant panda is highly specialized in its diet. Pandas have evolved from carnivorous ancestors. What? Pandas have evolved from carnivorous ancestors to subsist almost entirely on bamboo, a large but low nutrient grass. To require enough nutrients, pandas must spend as much as 16 hours a day eating. The panda's slow metabolism, slow movements, and low reproductive rate help it survive on this very specialized diet. Its narrow niche now endangers the giant panda, though as recent destruction of most of its native bamboo forests has reduced its range and its population to the margin of survival. The giant saguaro is also a specialist. It is slow growing and finely adapted to certain climatic conditions, but it cannot persist in wetter or cooler environments. Who was going to tell me that pandas' ancestors ate meat? That's insane. I didn't know that fact. That's a fact I didn't know. But now I do, and no one can ever take that away from me except for my own brain forgetting. Because of their exacting habitat requirements, specialists do not tolerate environmental change well and may adjust poorly to changing conditions. In contrast, generalists can easily switch their food source or relocate to a different type of habitat if necessary. Habitat specialists are therefore more susceptible to extinction when habitat is lost or fragmented. Often, specialists are endemic species. I know this one, actually, I know this definition. Endemic. It was kind of what they were talking about with specialized. Endemic means that you can only find it in one area. Like in a border, I think, even. Now let's get the actual definition. Definition time! Those found only in a particular place. Alright, well these definitions have been really shit recently. Often specialists are endemic. They occur only in one area or one type of environment. They gave it away as well. I'm sorry, there's just fucking banging and shit going on. The giant panda, for example, is endemic to the mountainous bamboo forests of southwestern China. The saguaro is endemic to the Sonoran Desert. In most organisms, genetic traits and instinctive behaviors restrict the ecological niche, but some species have complex social structures that help them expand the range of resources or environments they can use. Elephants, chimpanzees, and dolphins, for example, learn from their social groups how to behave and can invent new ways of doing things when presented with novel opportunities or challenges. In effect, they expand their ecological niche by transmitting cultural behavior from one generation to the next. Wow. Resource partitioning can reduce competition. When two species compete for limited resources, one eventually gains the larger share, while the other finds a different habitat, dies out, or experiences a change in its behavior or physiology. That reduces competition. Consequently, as explained by the Russian biologist G.F. Gauss, 1910-1986, complete competitors cannot exist. That's in quotations for all you Gauss heads out there. You probably knew that already. The general term for this idea is the principle of competitive exclusion. No two coexisting species can have identical niches for long. The species that is more efficient in using an available resource will begin to exclude the other. Now let's see if that's the definition that they said. No two species can occupy the same ecological niche for long. I see. Eventually, the other species will disappear or it will develop a new niche, exploiting the resource in a slightly different way. See, that's interesting in like a business sense, because if you think about like companies, that's basically what they're doing. Is it cold in here? Does anyone else feel cold in here? Reading time. When species with similar niches divide up a resource or segregate it in some way, it is known as resource partitioning. Partitions can allow several species to utilize different parts of the same resource and coexist within a single habitat. Species can partition a variety of resources, like food or nesting sites. Classic example of resource partitioning is that of woodland warblers, studied by ecologist Robert MacArthur. Although several similar warblers specialize, nope, I'm getting hit with a wave of sleepiness right now. Although several similar warbler species foraged in the same trees, they avoided competition by specializing in different levels of the forest canopy or in inner and outer branches. There's differences? You ever think about like how little we know? Not like the human species, but like person to person, how much we know and how much we don't know? Because I had no idea that birds as a whole, let alone warblers, were specializing in different levels of a tree. I didn't know that trees had different levels. The outer branches, the inner branches, the branches at the top are different than the branches at the bottom. It's just like branches, I thought. It was just branches. But it's not. They all specialize in doing different things. Look, here's a blurb about it. Hold up. Do you see that shit? Okay. See how it's showing like the different birds? There's like lines that you might be able to see that show like different levels of the tree. Here's what that says. Several species of insect-eating wood warblers occupy the same forest in eastern North America. The competitive exclusion principle predicts that the warblers should partition the resource, insect food, in order to reduce competition. And in fact, the warblers feed in different parts of the forest. So, then, coming from the business perspective and the me likening companies to this, what are they calling it? Probably not a good thing, but I can't recall what they're calling it. Resource partitioning. You telling me that like Google and Apple aren't in their little abodes and they're saying, hey, let's partition the resources being consumers? Because then there's less competition. All that they want is less competition. I guarantee you that the people making the Google Pixel phones are going to Apple and they're like, look, we don't want to fuck your shit up. So let's work together here and like not fuck each other. Or it's like a pure competition sort of situation and they really are trying to fuck over Apple, which is probably more likely if I had to guess. But it's an interesting thing to think about. Resource partitioning. Resources can be partitioned in time as well as space. Swallows and insect-eating bats both live by capturing flying insects, but bats hunt for night-flying insects while swallows hunt during the day. Thus, the two groups have non-competitive feeding strategies for similar insect prey. That's so interesting. Wow. Speciation, the process of creating new species, maintains natural diversity. As a population becomes more adapted to its ecological niche, it may develop distinctive traits that differentiate it entirely from its biological cousins. The splitting of one species into two different species is called speciation. There are two well-documented mechanisms of is it speciation? 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 Do any chatters know the answer? I can't move on until we know. Speciation. Most often involves genetic mutations in plants. Oh, fuck this word. Allopatric speciation. How are they doing that? Can occur when some kind of barrier isolates part of a population. Geographic isolation may develop, for example, as climate change alters habitat, as earthquakes or continental shifts separate land areas, or with sea level rise or island formation. We can see a recent example of reproductive isolation in populations of red squirrels in Arizona. In just the past 10,000 years or so, as expanding lowland deserts have isolated population on wooded mountains. You guys want to see this ship post? This is so funny, actually. Red squirrels. Land. Maybe it's just me. Maybe I'm a freak. I might be a freak. Be aware. It's 3:50. I still have only ever had that one viewer. But my stream still has yet to drop a frame. Oh my god, it scared me so much. I wish that was making a different noise. Hey, it's 5-minute break time. Fucking Christ, it sounds like a alarm. Something wrong is happening. All right, well, I'm all out of that one. Those are all empty as well. Let's talk to the invisible chatters. This one says +2. This one says +2, +2, +2. Thank you guys so much. Wow. There's no one here. But if there were people here, they would be entertained. There's no one here. Yet. No one here yet. What about a muffin? What about a muffin? I don't know, why am I doing that? I love making ugly faces, but then I just look fucking ugly and weird. I am weird, but like, worse. How am I supposed to get people to come to the stream? Let's open up the little stream thing here. Maybe YouTube will give me a recommendation and it'll say, here's how you can get people to come to your stream. First, you want to leak your stream key. Unlist live replay once stream ends. No, don't do that. If I leave this webcam, the stream can be accessed again from the managed list. Exiting will not end a stream if it is currently live. Okay. Well, no, I don't want to use my webcam right now. Okay, manage. This is my schedule. I just want to look at like the creator studio and they're going to be like, here's how you can bring more people to your streams. Can I change the name of this stream? Does anyone know? I don't know how. I don't even know if you can. Dashboard. Here's my live stream. How do I see go live? Set up, get Get set up to live stream now. Don't worry, you'll have a chance to review settings before you're live. Schedule a stream. Okay. Well, I'm already live, so just show me, give me back my... Oh shit, I'm opening my insurance. Okay. Live. Alright, I'm showing up to my own live. I can change... No, is this changing the title of the live stream? Because it's not called Trashton Live Stream. Channel content. Details. Trashton Live Stream. That's not what it's called. Surely that's not what it's called. It's not called Trashton Live Stream. It's called Trashton Live Stream? Who called it that? That's a stupid name. I am, parentheses, not studying. And then 25-minute pomodoro. Oh, pomodoro. Okay, save. I can't believe the title was Trashton Live Stream. No fucking shit, no one's here. What a bunch of baloney. Check the analytics. Oh, one person showed up and then they left after 2. Oh my Christ. All right, 5 minutes is up. Y'all ready to get back to it? Back to reading. Get your books out. Maybe changing the name of the fucking stream will help. The only drink I have up here is cold brew coffee at 4 p.m. I will make my heart explode. I'm thirsty. My Choose Goose came out there. I'm sorry. If you didn't know, I was the voice of Choose Goose on Adventure Time until they had someone replace me. That's not true, by the way. Don't put that in the wiki. Or sue me. Don't sue me either. All right. 25 minutes is up. Well, we're starting again. We're reading about the fucking environment. All right. So yeah, we're talking about endemic species, and that was like aloe something endemic. I don't know. Anyways, actually, I would like to see my... No, not that one. The timer is started as well. I'd like to see my analytics. Reach. Traffic sources notification. Okay, so one person came from a notification. That's my only view. Wow, and they left immediately. Okay. Well, this is not helping me in any way, shape, or form. Reading time! The barriers that divide subpopulation aren't always physical. For example, 2 virtually identical tree frogs live in similar habitats of eastern North America, but have different mating calls. This difference, which is enough to prevent interbreeding, is known as behavioral isolation. Behavioral isolation allows the 2 different species to evolve in the same geographic area at the same time. Really interesting. 2 identical tree frogs. Barriers that divide subpopulations aren't always physical. Speciation or speciation that occurs without a geographical barrier. Sympatric speciation is common in plant populations. It is made possible when chromosome separation occurs during the cell division of plants. When plant chromosomes do not separate fully into 2 cells. There can be more than 2 full sets of chromosomes in a single plant. Fern species and other plants sometimes undergo sympatric speciation by doubling or quadrupling the chromosome number of their ancestors, which makes them reproductively incompatible with the parent population. That's so interesting. Environmental changes can make certain traits advantageous in a population. In the case of the Galapagos Island finches studied by Charles Darwin, for example, an extended drought reduced the ability of small seeds on some islands. Large-billed individuals in the finch population had better success in opening the remaining larger seeds. Within 2 years, the large-billed trait came to dominate the population. The shift toward one extreme of a trait is known as directional selection. Environmental conditions may also make intermediate traits advantageous, producing stabilizing selection. Competition can cause... Oh, period. Is my timer not going? That's probably fair, honestly. I've not been paying the most amount of attention with the other ones, so I earned my time back now. Environmental conditions may also make intermediate traits advantageous, producing stabilizing selection. Competition can cause divergence of traits and niche specialization. Disruptive selection, which allows for better partitioning of resources. They're showing me a diagram with a bunch of birds. Again, it's just so hilarious. You see that? Look at it. Look at the bird faces. That's so silly. Yes, we have original variation. That's in the top left quadrant. And that splits into stabilizing selection, directional selection, and disruptive selection. A species trait, such as beak shape, changes in response to selection pressure. Suppose a population starts with wide variation in beak shape, A, the one in the top left. Sometimes selection pressures advantage just one beak type, which becomes dominant. Sometimes an intermediate or average type is advantageous. Disruptive selection moves characteristics to the extremes of the trait. Okay, very interesting. Directional selection can be observed in many cases. Arctic foxes, for example, occupy a landscape that is snowy in winter but grassy in summer, with very little cover to hide in. This environment favored individuals whose winter fur molted to white and whose summer fur was brown, which concealed them from predators as well as from prey. In a process of directional selection, foxes that lacked this ability to change colors died, leaving the more extreme trait, contrasting seasonal colors, dominant in the population. We also see directional selection in the emergence of antibiotic-resistant bacteria. In this case, an environmental stressor, antibiotics, kills off most of a bacteria population, but a few individuals that happen to have better than average tolerance of antibiotics may survive. Resistant survivors produce new generations, leading to a population with resistance to the antibiotics. Maybe I should mute myself for the studying time while the timer is on. But I feel like then I would have to have like music or something in the background. I don't know. Well, you know what I'll do is I'll look at is it Jay Scholl, the guy who studied for like 12 hours and live streams himself studying all the time. I'll just go rip off that format. Identically, actually. I'm going to steal assets. I'm going to remake his set. Just take over his entire identity. And then I will be YouTube famous. Finally. Resistant survivors produce new generations. Did I read that? At the same time that I feel like I read all this, I don't remember any of this. We also see directional selection in the emergence of antibiotic-resistant bacteria. In this case, an environmental stressor, antibiotics, kills off most of a bacteria population, but a few individuals that happen to have better than average tolerance of antibiotics may survive. Resistant survivors produce new generations, leading to a population with resistance to antibiotics. That's fucking crazy. Evolutionary change is typically slow. We generally believe that species arise slowly, and in fact, many have existed unchanged for tens of millions of years. The American alligator, for example, has existed unchanged for over 150 million years. That's got to be some kind of world record. Go alligators. Some organisms, however, evolve swiftly. New flu viruses evolve every season, and fruit flies in Hawaii mutate frequently and can give rise to new species in just a few years. Given these examples of rapid evolution, why can't organisms adapt rapidly to changes we are making to our environment, such as climate change, pollution, and habitat fragmentation? Species have evolved before. Why can't they just do it now? There are several answers to this question. First, the frequency and intensity of modern environmental disturbances is unprecedented in geologic history, and the natural frequency of random mutations, required for evolution, is low. Second, genetic mutations cause change over generations, and many species have a long lifespan or age of reproductive maturity. For example, each female lake sturgeon takes 14 to 33 years to reach sexual maturity, and then it only spawns once every 4 to 9 years. Orange ruffy which is a species, apparently. That sounds like an Urban Dictionary definition. I want you to give me an orange ruffy. Jesus! Why did I say that? Why did I say that? The fuck was that? There's someone screaming outside. Alright. Well, orange ruffies grow very slowly and can live for 150 years. They don't begin to breed until they are at least 20 years old. Alright, a third reason that species cannot easily or rapidly adapt to changing conditions is because species do not evolve alone, in isolation. Instead, species evolve over millennia as part of a biological community, and they are embedded in a complex web of interactions that include competition, predator-prey relationships, and symbiosis. These geological and ecological interactions are discussed in sections 4.2 and 4.3. We're still in section 4.1? Oh my god, it takes so long to read a book when you're reading a book out loud to a bunch of... Actually, no one. No one's here. No one has ever been here. Still not a single dropped frame, though. See if your favorite streamer is dropping frames, because I'm not. Taxonomy describes relationships among species. Evolution has produced a bewildering variety of organisms. How can we make sense of them all? Taxonomy, the study of types of organisms and their relationships, help biologists organize and understand biological diversity. Taxonomy identifies similar traits to trace diverse organisms back to common ancestors, as in a family tree. We often use the most specific levels of the family tree, genus and species, to compose names called binomials. I thought that was a math thing. Also called scientific or Latin names, binomial names identify and describe species using Latin or Latinized nouns and adjectives, or names of people or places. The first word in a binomial indicates the genus of the organism, while the second word designates the species to which it belongs to. You can see examples of these binomials throughout this chapter. I've been not reading them because I don't know how to pronounce Latin. I'm not Latin. Scientists communicate about species using binomial names instead of common names, such as lion, dandelion, or ant, to avoid confusion. A common name can refer to a number of species in different places, and a single species might have many common names. On the other hand, the binomial Pinus resinosa refers to the same type of tree whether you call it a red pine, Norway pine, or just pine. That was a close one. I almost got by my own textbook. They almost got me, but they didn't. Taxonomy defines relationships from broadest to most specific levels. The binomial Pinus resinosa indicates the detailed levels of genus, pine, and the species, the type of pine. Similarly, you are Homo sapiens, genus Homo, and species sapiens, meaning wise. You and the pine represent two well-known examples of the 6 kingdoms into which taxonomists organize all living organisms: animals, plants, fungi, protists, bacteria, and archaea, or archaeobacteria, ancient single-celled organisms that live in harsh environments such as hot springs. Within these kingdoms are millions of different species, which you will explore more in chapter 5 and 11. That's pretty crazy. I thought, yeah, wait, weren't there 3 animal kingdoms? When did they add 3 more? Dude, if you stop studying and you don't like religiously keep up with the news, you're living in a different world. Because in my understanding of the planet, there are 3 animal kingdoms. But it looks like the fact of the matter right now is that there are 6. I wasn't living in this world. Now I just entered it, but that's crazy. Okay. Hey, we're in 4.2 now. We were in 4.1 that entire time, but now we're in 4.2. Yay. Species, interactions, and the evolutionary process. Oh my god. I need like a Germa burp muting button. All complex organisms have evolutionary relationships with other species. Predation is an important type of selective pressure. Symbiosis involves long-term biological interactions that benefit one or both species. Keystone species serve a fundamentally critical role in an ecosystem. Oh, actually, before we read this, we should take the test. That way I can get a bit of a break from the monotonous reading, and you can get a break from the monotonous reading, and I get to test my knowledge. It's a little win-win scenario. My session is timed out. Okay, well, make my session come back. All right, here we go. I don't know if you all are ready for this. There's a chance that you all are not ready. A very good chance, actually, because if you weren't paying attention, I mean, the quiz is here. I don't know what to tell you. You had time. All right. Which of these ecosystems is very productive, supports hundreds of species of invertebrates, mollusks, fish, and mammals, and is located along temperate and tropical coastlines? I have a feeling that this was in the intro that I didn't read because I didn't realize you're supposed to read the intros. Like, why quiz me on this? It's so, like, I mean, it's seagrass ecosystems, right? I'm going to put medium. Yeah, it's seagrass ecosystems. All right, well, whatever, dude. The idea that that entire populations of species change over time to become better adapted to their environment is called, is that evolution? Evolution. Yes, it is. Guys, we're so smart. Choose the 3 phenomena that are the causes of evolution. Selection, replication, variation in traits, which would mean that predation. Oh man. The 3 phenomena that are the causes of evolution. Well, here, I can open it up in the book really quick and I can see what the answer is. So, replication, I had, variation in traits, and selection. Okay, so I actually had it, but I didn't, like, I get like half points on that one because I was right, but I didn't know why. Availability of water, space, and food are all examples of blank factors that influence the fitness of individuals. The availability of water, space, and food. These limiting factors? I only remember hearing about limiting factors. I got it right. Woohoo! The physical location and environmental conditions under which a given organism lives is its key. The physical location and environmental conditions under which a given organism lives. Habitat? I mean, realistically, I would look this up, but it's habitat. I feel like that's more memorable. Doing the Hail Mary long shot and getting it right, more memorable than just looking in the book and seeing it. Seagrass ecosystems contain many different species of plants and animals. Can I choose multiple? I can. Grow on rocky substrate? I actually just don't know because I didn't read this. Let's give it a read. It's kind of long, but it looks like this quiz is going to continually ask me questions about seagrass meadows. So we're back to reading. Seagrass meadows, the planet's hidden productivity powerhouse. Have you ever seen someone standing in shallow water peering down into their mobile phone? You may have spotted an intrepid citizen scientist contributing to marine conservation using the Seagrass Spotter app. Okay, shameless plug. Seagrass meadows are in trouble worldwide, disappearing at the same rate as rainforests and coral reefs, but few people even know they exist. The Seagrass Spotter project lets people around the world identify seagrass species and upload an image of the plant to an online map. Their input provides data for a growing crowdsourced planetary inventory of seagrass ecosystems. Online, we can see that people everywhere, vacationers at the ancient ruins of Lipsi, Greece, residents in Rameswaram, India, snorkelers in Changi Beach, Singapore, and couples on an after-dinner stroll in Mapua, New Zealand, have all contributed to conservation science with just a tap on their phone. Why does the Seagrass Spotter project enlist the public's help to find seagrass meadows? Because these hidden ecosystems are powerhouses of biodiversity and productivity, and they deliver many benefits to us directly and indirectly. Seagrasses are submerged, often deep-rooted plants that grow along some 600,000 square kilometers of the world's tropical and temperate coastlines. Because they photosynthesize, the plants typically occur in shallow ocean waters between 2 and 12 meter deep, but they can occur down to 50 to 60 meters if water is extremely clear. Plants from extensive underwater ecosystems that can contain almost 1,000 different species of plants, invertebrates, mollusks, fish, and marine animals. The plants form. Oh, form, not from. Okay. That was one of the answers, I think. Seagrass systems are among the most productive ecosystems in the world, more productive even than coral reefs, although reefs may have greater species diversity. While plant productivity and ecosystem services vary with geographic location and the type of seagrass present, seagrass communities form the primary production base of many coastal food webs. Even small areas of seagrass can yield big benefits. In the Mediterranean, seagrass covers less than 2% of the sea floor, but seagrass-associated fish and invertebrates comprise 30 to 40% of total value of the commercial fish catch. Wow. Seagrass meadows are especially important on a planetary level because they deliver essential ecosystem services that benefit our lives, both economically and environmentally. They act as an enormous oxygen pump. 1 square meter can generate 10 liters of oxygen every day. Their extensive network of roots and rhizomes trap and stabilize sediments on the sea floor. This helps control erosion, improve water clarity, and provide protection against floods. Seagrass meadows perform a particularly important ecosystem service by capturing carbon dioxide through photosynthesis and storing it as organic carbon in the seafloor soil matrix. This blue carbon, organic carbon sequestered by coastal ecosystems like seagrass meadows, tidal marshes, and mangroves, is crucial for mitigating climate change. Seagrass meadows can store twice as much carbon as forests do. Coastal mangroves can store 4 times as much. The carbon storage capabilities of seagrass meadows are tremendous for their size. Although they cover only 0.1% of the seafloor, they provide 10% of ocean carbon storage. This is a crazy plant slash ecosystem habitat. Seagrasses are essential to the structure of functioning of coastal systems and to the people that depend on them, but we are losing them at an alarming rate. In 2018, 140 ecologists from 35 countries sent a distress signal by declaring an international call to action, calling for increased conservation efforts, including management, monitoring, and protection. They warned that the loss of seagrass meadows threatens hundreds of millions of people with increased poverty, hunger, and disruption. What threatens seagrass meadows? Runoff of fertilizers, pollution, and sediment is common. Dredging for ship canals, overfishing, and disease are widespread. Warmer ocean temperatures exacerbate these stressors. Yeah, those meadows are gone. We're not stopping that shit in time. That's insane. But we can help these hidden gardens stay healthy and resilient. Everyone who visits sandy shorelines can help find and identify the grasses through programs like Seagrass Spotter, shameless plug, #ad. We can promote their conservation through the media. Boaters can use low-impact anchoring systems to reduce damage. Communities and coastal managers can minimize the impacts of coastal development and destructive fishing practices and reduce erosion and surface runoff. There are good reasons to be optimistic about seagrass meadows. Increasing evidence shows that they can be restored, and governments are showing interest in seagrass conservation as a tool for climate mitigation. You can be part of the solution by understanding and embracing the positive and powerful role of these secret gardens. In this chapter, we consider some of the ways species adapt to their environments, interact, and shape their biological communities. We also examine effects of disturbance on those communities and properties that contribute to resilience in the face of environmental change. All right, back to the questions. Seagrass ecosystems, they do not grow on rocky substrate, as far as I read. They don't mostly occur in deep waters, but they do contain many different species of plants and animals, and they are very productive. I got it right. We got it right. Sorry. Couldn't have done it without your help. Still 0 people here. There has not been a single person. Actually, I don't know if there's been a single person that's joined since then. If they joined in the last whatever, then they came to just literally me reading. Oh, you know what? I closed it out. Let's see if I can open it back up. I know I'm on the timer right now, but I have no self-control or discipline. Just part of why I'm doing this. Hey, look, there I am. I'm on my own. Why did they choose that thumbnail? What the fuck? Why did they choose that? I look like such an asshole. What the fuck is this? I wish I could show you this. Actually, I think I can show you this. Image. Browse. Yeah, look at look at this shit. Why did they choose this as the thumbnail? Studying for business major makes fucking disgusting male face, and then this looks like are you sure you want to remove image? Yes, I am. I don't look like that. I look nice. I look like a normal, I mean, I look nice. I don't look like, that's the face I'm doing. Watch just steal that one too immediately. It's like, he did it again, catch it, he did it. Put that as the thumbnail right now, he did it again. What an idiot. Oh my god, okay, I just want to look at my stream and see what the fuck is going on. Oh my god, I can hear me. What is that? He did it again. What an idiot. Am I clipping? Oh my god, okay, I might be clipping. I think when I yell. That was the last thing I said. Okay, we've started a loop. I really needed to hear if I was clipping or not. All right. Analytics. Has anyone been here in the last? Who knows that? No, it's still just that one person at 3 p.m. All right. So I forget why I was looking that up in the first place, but anyways, that there's no one here. The functional role that a species plays in its environment is called its ecological niche. Functional role that a species plays in its environment, ecological niche. Yes. All right, my insane, stupid timer is going off in a second again. It's going to sound like the end of the goddamn world. I'm ready this time, though. I got my mouse on the button. You can see it. Ready? Okay. Whew. That wasn't that bad. All right, and then I have to go over here. I'm going to find a better way to do this and enable the break timer. We are on break right now. Oh! Oh my God. You ever just, you ever do a stretch and it is just the best fucking thing in the entire world? My lower back just had a very good time. I have nothing to drink. I might, to be honest, I might end the stream because no one is here. I've been streaming for 2 hours to nobody, and I don't know, I'm tired. No one's here. I don't know anyone. I don't have any friends. I don't know anyone. I live with my girlfriend. I go to work. I have coworkers. But I'm not going to tell my coworkers, hey, come to the stream. I'm going to study and read. And then even then, there's like 3 people that I actually like there. So how in my right mind am I meant to get anyone here? I don't know. Maybe. I'm gonna not talk my mouth full. Okay. Maybe. Because I love streaming. Maybe I stream other things and then like things that are actually interesting. And then some people might want to study with me as well. I'll get them from that. But I have to actually stream. Because I was streaming on Instagram, right? Listen to this. The camera's up here. Listen to this. It's not actually that serious. I'm just venting. I was streaming to Instagram. And I was doing it pretty often. Making music, and I got a whole setup going. I had this webcam. I bought like a little Bluetooth numpad to change my OBS scenes, so you could like top down look at my music setup, and then like 3/4 angle look at me and my music setup, and like I got all these lights and stuff to make it look nice. I didn't get it for that reason, but like I put a lot of effort into making my stream look very nice, and I had a very, very good time streaming. And you might be asking yourself, where is this story going? They took away streaming for people that aren't like with 1,000 followers or something like that. So you are not allowed to stream anymore if you have less than 1,000 followers. And I don't know if that's supposed to be like you're not a real account. You haven't been around long enough. If you don't have 1,000 followers, like you're fucking poor. Or if I don't know what, but I don't have 1,000. I had like 200 something followers because I basically bought them by running an ad campaign. And literally, I can't stream there anymore. I had a routine going. I was settling into a schedule where I would make music, and I mean, I had to stop anyways because like I got extremely busy with school. But they took that away. Can you believe that? I stopped looking at the camera again. I'm just looking at myself, my own face. But can you believe that? That's just the most horrible thing. I had something going on there. Do I end the stream? Why don't we do one more session? Another 25 minutes. So stream's ending in 25 minutes. Still not a single dropped frame. Oh, I wish people were here in this chat. I wonder how many people stream with 0 followers and viewers, and how long they stream to their 0 viewers. All right. Oh, something in my eye. Oh my god. It's an eyelash. I'm better now. All right. Timer started. We are back to doing actual work. The change in the inherited characteristics of biological populations over successive generations is called evolution, or is it mutation? The change in the inherited characteristics of biological populations over successive generations. I'm going to say evolution because I feel like we haven't gotten to the mutation part yet, and they're just trying to make sure that I understand evolution. Yes, it is evolution. No two species can exist in the same habitat and fulfill the same role indefinitely. This is the principle of competitive exclusion or natural selection. Competitive exclusion sounds good, and it's correct. Replication through reproduction, traits variations, and selection are the phenomena that results in evolution. You should know that one by now. Putting high confidence on that one. The development of a new species is called speciation. If I can spell it right, because if I spell it wrong, it's wrong. I have to spell it right. I got it right. I know how to spell, and also I know how to think about things that I just read, and when they're asked of me, say them. So I'm pretty cool, actually. Just throwing that out there might be kind of cool. Where a species can live is dictated by blank factors, such as the temperature and pH in the environment, competition with other species, and the presence of disease. Oh, something factors. Where a species can live is dictated by blank factors. Evolution, habitat, environment. I know the factors part. I know there's like one word that ends in one phrase that ends in factors, but I need to go back and look at this. Limiting factor. Oh, I wasn't gonna get that. But like when you say it, I know it, but that's not knowing something. Limiting factors. I'm putting low confidence for that because I shouldn't have had it. Allopatric speciation results from the isolation of a population. I just remembered that one because allopatric is an interesting word. The environmental conditions in which an organism lives is its key habitat. High confidence. Species cannot rapidly adapt to current environmental changes because, and I can select all that apply, they mutate frequently. No. They are small in size. No. Some species are very long-lived. The changes are overwhelming in number and intensity, and species don't evolve in isolation. That's not true. So these are the answers. Species don't evolve in isolation. Oh, I see what they're saying. Oh, that's a bit of a tricky one to understand. Because what I thought when they said species don't evolve in isolation is like if you take a species and you put it in like a very secluded area, it won't evolve. And I think that that's not true. But what they're saying is that species cannot rapidly adapt to current environmental changes because species don't evolve in isolation, as in like species are evolved in major, maybe I should have had that one. I just didn't think that hard about it. Species don't evolve in isolation. I don't think there's a single species in isolation. It relies on something else. So should have had that one. Well, I mean, I should not have had that one, and I didn't have that one. So I'll get it next time, though. The manner in which a species obtains food, the relationship it has with other species, and the services it provides to the community are all part of its ecological. I don't know off the top of my head. The manner in which a species obtains food, the relationship it has with other species, and the services it provides to the community are all part of its ecological role, niche, ecological niche. All right. So I'll write that in, but again, I shouldn't have had it. I looked it up. I hate that it's open book. Hot take. Open book has saved my ass probably for every single test that I've ever taken because every single test is open book. But I feel like if you need the book to answer the question, you didn't learn it. And I understand the old argument of like, oh, you're not going to have a calculator in your pocket at all times, and so you need to know this math, and like now everyone has a calculator in your pocket. That argument I understand, like it's irrelevant anymore. Those people got proven wrong. But like, if you, let's say you're an accountant and you're sitting at your desk and you are struggling to understand concepts and you're continually opening up your book, you're not an accountant. You are someone who pretends to be an accountant, and you're constantly looking up how to do things in your book. Maybe that's kind of a crazy example, but like I feel like America is dumb. I feel like America's dumb. Hot take. I feel like we are fudging the numbers and making tests easier so that our numbers look the same on the international levels, but they're not at all. Because the open book should not be a thing in my hot take opinion. I did say hot take. I said hot take. In my hot take opinion, open book, and like some classes are even doing like open internet, open AI. I don't have to talk about that. You already know what I think about that. All right. The study of different types of organisms and their relationship to one another is ecology. Surely. Taxonomy. The study of different types of organisms and their relationship to one another is taxonomy. All right, that makes sense. That's an example of me, like, I just didn't know it. I was just using, like, deductive skills, like, oh, well, it's an environmental science class, so, like, ecology, no, it's not. The idea that no two species can occupy the same ecological niche for long in a given ecosystem is summarized in the principle of competition exclusion. High. What? Okay, that's It's not the principle of competition exclusion. It's the principle of competitive exclusion. And now I need to review some sort of chapter or something before I can move on. That's kind of cheap. You know what I meant. If I call it competition exclusion versus competitive exclusion. Oh well. Right after my rant as well about everyone having their grades inflated. When a population of a species becomes more adapted to its environment, developing specialized or distinctive traits, it eventually differentiates entirely from the original species, resulting in speciation. Yeah. Process over which predator and prey exhibit physical and behavioral changes in response to selection, pressures from one another is that natural selection? The process over which predator and prey exhibit physical and behavioral changes in response to selection pressures from one another. My best guess is natural selection, but I am going to look it up. Coevolution, when two or more species affect each other's evolutionary process, called coevolution. Oh, this was a 4-2 term, and I haven't done 4-2 yet. So I'm going to write coevolution. Yeah. But if they keep giving me questions like that, I'm going to have to go back and start reading again. The type of speciation that results when a population of a species is geographically isolated is allopatric. I know that one. It stuck out, such a strange word. Under the ecological definition of a predator, an herbivore is a predator of a plant. This is definitely some 4-2 stuff. I'm not even going to try to answer this one. I think we need to go back to reading. Fortunately, because I'm kind of burnt out of reading, but we got to go back to reading because I can't answer those. All right, so 4-2 is species interactions and the evolutionary process. All complex organisms have evolutionary relationships with other species. Oh my goodness, excuse me. Predation is an important type of selective pressure. Symbiosis involves long-term biological interactions that benefit one or both species. Keystone species serve a fundamentally critical role in an ecosystem. Over many millions of years, species evolved to better fit the environment, and part of their environment includes the presence, behavior, and actions of other species. In fact, much of the evolutionary process is shaped by species interactions, and these species interactions create the web of life. When two or more species affect each other's evolutionary process, it is called coevolution. We just learned about that. Co-evolved relationships can involve antagonistic or mutually beneficial cases. Because no species lives in isolation, all complex organisms demonstrate the influence of coevolution. In fact, one of the most fundamental facts of biology is that specialized co-evolved relationships form the base of all natural ecosystems. A little fun fact for you all there. I didn't know that one. Predator-prey dynamics assert selective pressures. I'm hearing the resonant frequency in this room. There it is. I'm sorry for screaming into your ear. That's terrible, though. I'm going to mute myself, actually, and keep doing that. Yeah, that was really bad. Okay, continuing on. Almost everyone is familiar with predator-prey species interactions. To understand its pervasiveness, we need to revisit our discussion about trophic food webs. As we saw in Chapter 3, Food webs begin with a simple fact. All organisms need food. Producers like plants and algae capture energy to create organic molecules through the process of photosynthesis, while consumers eat organic matter created by other organisms. Consumers include herbivores, carnivores, omnivores, parasites, scavengers, detritivores, detritivores, and decomposers, fucking musicians. You got carnivores, herbivores, omnivores, parasites, scavengers, detritivores, and producers, music makers, those fucking beat makers out there eating the fucking drone beats off the ground. Funny joke, +2s in the chat, still 0 people here, still 0 frames dropped though, so I don't know. We often think only of carnivores as predators, but in an ecological sense, a predator is a consumer that feeds directly on another living organism, whether or not the predator kills the prey. So going back to the test here, our answer is true. Under the ecological definition of predator, an herbivore is a predator of a plant. That's true. That's fucking weird. That's crazy. Wow. Okay. Let's see if we can answer this next one on the test. A species that evolves rapidly and in relative isolation from another species would be blank to adapt to environmental change, less likely or more likely. Species that evolves rapidly and in relative isolation from other species. I think that they would be less likely to adapt to change because they would become more specialized. I was wrong. How is that true? A species that evolves rapidly and in relative isolation from another species would be more likely to adapt to environmental change? I guess they are evolving rapidly, and they're not that dependent on other things. They're in relative isolation. That does make them okay. We might read about that in this. Hopefully we haven't already read that one, but all right. We read this. Herbivores, carnivores, and omnivores, which feed on live prey, are predators, but scavengers, detritivores, and decomposers, which feed on dead organisms, are not. In this sense, parasites, organisms that feed on a host organism or steal resources from it without necessarily killing it, and even pathogens, disease-causing organisms, can be considered predator organisms. Herbivory is the type of predation practiced by animals that graze and browse on plants. Very interesting stuff here. Predation has a powerful but complex influence on species populations in communities. It affects 1. All stages in the life cycle of predator and prey species, 2. Many specialized food obtaining mechanisms, and 3. The evolutionary adjustments in behavior and body characteristics that help prey avoid being eaten and help predators more efficiently catch their prey. All right. I'm rereading this to myself. Predation has a powerful but complex influence on species populations in communities. Okay. Let's first examine predation through the life cycle of an organism. An organism's predators and its position in the food web can change as individuals mature. In marine ecosystems, crustaceans, mollusks, and worms release eggs directly into the water, where they and hatchling larvae join the floating plankton community of small and microscopic organisms. Okay? We're studying the context here. Planktonic animals eat each other and are food for larger carnivores, including fish. As prey species mature, their predators change. Barnacle larvae are planktonic and are eaten by small fish, and as adults, their hard shells protect them from fish, but not from starfish and predatory snails. I'm losing steam. You can tell I'm losing my mind right now. We got 7 more minutes. Predators often switch prey over the course of their lives. Carnivorous adult frogs usually begin their lives as herbivorous tadpoles. Predators also switch prey when their original prey becomes rare or something else becomes abundant. Many predators have morphologies and behaviors that make them highly adaptable to changing prey base, but some, like the polar bear, which eats seals, are highly specialized in their prey preference. Polar bears only eat seals? Like, that's it? They don't eat anything else besides seals? Seems they should, like, upgrade, maybe. No shade to polar bears. They probably need help, but, like, you gotta find some other stuff and eat it. Predator-prey relationships exert selection pressures, fucking Christ, that favor evolutionary adaptation. This occurs when predators become more efficient at searching and feeding on prey, and the prey become more efficient at escape and avoidance. An evolutionary arms race can occur between predator and prey, as each party enhances its predatory or defensive traits in response to the other. Toxic chemicals, body armor, extraordinary speed, and the ability to hide are a few strategies organisms use to protect themselves. Plants have thick bark, spines, thorns, or distasteful and even harmful chemicals in tissues. Poison ivy and stinging nettles are examples. Arthropods, amphibians, snakes, and some mammals produce noxious odors or poisonous secretions that cause other species to leave them alone. And what do we have? A classic example of an evolutionary arms race is the relationship between the rough-skinned newt and its predator, the common garter snake. Biologists in Oregon discovered rough-skinned newts carrying a neurotoxin called tetrodotoxin, TXX, that was 2 to 3 times stronger than the venom of the world's deadliest snake. Oh my god! In Oregon? I live in America. It's nowhere near where I live. Some rough-skinned newts were so poisonous that the amount of toxin in a single individual could kill 50,000 mice or over 100,000 people. Wow, 100 people versus one rough-skinned orange boy. Why were the newts producing such extreme levels of TTX? That's a great question. The researchers hypothesized that a newt-eating predator must be resistant to large amounts of TTX. They found that the common garter snake. Wait, Gartner? What is Gartner the, like, belt? Or is it garter? What is Gartner? It's a research and advisory firm. Gartner belt. No, it's garter belt. Well, why is it called a garter snake? Do they look like garter belts? Why are they called that? Wait, this calls for research. In my last 3 minutes, why are garter snakes called garter snakes? I was right! Sorry for screaming. Garter snakes are named for the long stripes on their backs, which resemble the strips of fabric or garters that people once used to hold up their stockings. Boom! Boom! Is he eating something? No, he's resting on a rock. Okay. Look at that! Stay curious. Stay curious, everybody. You never know what you might learn. I'm learning right now. You learned just now if you were here. 0 viewers still? We still got 0 viewers? A second person came in. Wait, and a second person is here right now? What? What? Who are you? Show yourself. Who are you? Make your presence known. I don't know I don't check this very often. So someone, yeah, okay, so someone at 4 30 something popped in here and then left and then like maybe came back. Someone's here right now, guys. Fucking. Oh, I see. Wait, why is chat's not showing up on the OBS? Hold up. I see what you're saying about my Lego skeleton, but you have also just informed me that chat is not showing up on OBS. Is it cut off? Okay, well anyways, that Lego Skelly is sick. Thank you. That's our Lego Skelly. Skelly boy. He's really bright right now. Hold up, I can change the light on my lighting app. Bear with me here. How do I do it again? Candle. Yeah, here we go. He looks crazy in blue. Like his shadow, he looks like he's powering up. Ah! Ah! That's the noise that he'd be making if he could scream. So I did it for him. I like to keep it orange though, because it feels warm in here. Amazing. Wow, yeah, I don't know why OBS is not showing the that message. Unless I have oh. Here we go. Are we gonna see the message soon? I'm enlarging. Wait, no, it's just not showing it. Huh. Weird. Okay. Well, yeah. Lego Skelly Boy is with me at all times. Oh my Christ! God, that timer going off scares me so bad. Who are you? Enhance. Pokemon profile picture? Anyway. That doesn't matter. I don't know why I said it that way. Well, unfortunately for you, and also me as well, at the end of that timer is when I intended on ending this stream. So someone eventually showed up. I've been streaming for 2 hours, reading about books and whatnot. This stream's a mess. But it was the first one, so we'll figure it out later. And I still can't figure out how to look at chat. Maybe I need to, I need to pop out this chat, I think, because this chat shouldn't be here. So is the old chat the old chat? I think it is. Okay. What is this purple thing next to your name? You're #1 fan. You have 25 XP. Holy shit. You're insane. You've got so much XP. How much XP do I have? I don't have XP. All right. Pop out chat. Pop out chat, and then apparently OBS does not like this chat. So we have to find the actual chat. There it is. But it's huge. How big that chat is. Then what is this other window? Oh, it's here now. In the world? That's so strange. Wait, so can I put it back on the other one? This is not me ending the stream. Yeah, look, there you are now. What the heck? Yeah, I don't know. Weird. Anyways, yeah, unfortunately, I'm leaving now. But you came to hear about some, I don't know, what did you even hear about? Like the newts and the snakes or something like that? Well, anyways, I will hopefully do more these sort of talking, studying, not studying streams. I'm still figuring them out. I need to watch some other people in how they do their studying streams, because I was like reading aloud because that helps me understand better, but then I was thinking if someone's here to like study along with me, they're gonna have to mute my stream. So anyways though, I can see exactly how long you have been here. They're telling me 13 minutes and 31 seconds. So thanks for being here for the 13 minutes and 31 seconds. I'll be streaming sometime soon. I have a lot of studying to do, so maybe username is like Chi12 TER cheater 12 cheater 12. Lock that into my brain. I'll see you later.